Hey guys, this is going to be a video that goes through the solutions for our final exam review day 4 on trig and periodic functions. All right, so starting with question 1, we've got a trig equation here. The goal is to isolate the trig function, so I'll subtract 1 and then divide by 2. So we've got sine x equals negative 1/2. Solving for x, it's going to give us inverse sine negative 1/2. All right, well, a couple things we want to remember here. Number one, inverse sine is going to be negative. So let's remember our quadrants, A, S, T, C. And where is sine negative? It's going to be in the third quadrant and the fourth quadrant. So all of our solutions have to be in those quadrants. Now, the other thing we need to remember is that our domain is from negative 2 pi to 2 pi. So we're going around the unit circle from 0 to 2 pi, and then from 0 to negative 2 pi. Now we should know this from our trig unit. Where is sine 1/2? That's going to give us a reference angle, and that's going to be 30 degrees, but we want radians, so that's going to be pi over 6. So my solution for x is going to be the reference angles in the third and fourth quadrant using pi over 6. So remember, this is going to be 6 pi over 6. I need one more than that. That's going to give me 7 pi over 6. And then all the way around to the fourth quadrant is going to be 11 pi over 6. Going backwards now, that's going to be negative pi over 6, and it's going to be negative 5 pi over 6. So we've got 4 angles that satisfy this equation that are between negative 2 pi and 2 pi. Okay, next question. This is either going to be law of cosines or law of sines questions. What we want to do is we want to make sure we set up this triangle correctly. So first, let me just sketch triangle. Angle A is 36 degrees. So here's angle A, that's 36 degrees. Angle B is 72. Doesn't really matter where you put it. Just make sure you label that as 72. Side C. So this vertex has to be C. The side opposite that is going to be 8. So looking at what we have here, we've got 2 angles and we have a side. So this is going to be law of sines, but I need to find this angle first, and I'm going to find that angle by subtracting 36 and 72 from 180, and that just so happens to be 72. So now here's how law of sines works. I need to find side A. So I'm looking for this right here. So what we need to do is we need to use the side and the angle opposite and the side and the angle opposite. So I'm going to set this up. A over sine 36 equals 8 over sine 72. And I always like to put the variable here because that just means to solve this equation, I have to multiply both sides by sine 36. So if I do that, those cancel. Obviously, I'm going to get a value for A here, and you just need to plug all of this into your calculator. Please make sure you're going to be in degree mode for that. Let me check mine. I got 4.9. All right, question 3, we're getting into our periodic functions here. Identify the midline, amplitude, frequency, and period of this function. Now, sometimes what they do is they take that vertical shift and they write it first. If that kind of confuses you, you can just kind of rearrange this equation so it's negative 3.5 cosine 4x, and then put a plus 14 on the end. Okay, so I'm just going to illustrate the different parts. That's my amplitude. Remember, that's your B value or frequency, and that's going to be your midline or your vertical shift. And one equation that we need to know to get period equals 2 pi over B, or sometimes referred to as 2 pi over the frequency. Okay, so we just need to list these things out now. So amplitude, obviously, is going to be 3.5. My frequency is going to be 4. So my period is going to be 2 pi over 4. You can keep it like that, or you can list it as pi over 2. Let's see, the midline. Now, you have to be careful here because it specifically asks for a midline. So it's the equation of a line. You can't just give a value. So that's going to be y equals 14 in this case. Okay, this question here is very interesting. It says let s equal f of x equal 5.3 cosine 3x plus 4.8. Write a formula for the function r equals f inverse of x. So this is really an inverse function question. We covered this in day one, but this is a good application using a trig function. So first thing I like to do is just kind of think of this as a y, and anytime you want to come up with the inverse of a function, you're going to switch x and y and then solve for y. So let me rewrite this as x equals 5.3 cosine 3y plus 4.8. Now I'm going to go through the basic algebra kind of quickly. First thing you want to do, well, not the first thing, but the goal is to isolate this and then eventually isolate that. So first thing I'll do is subtract 4.8 and I'm going to divide by 5.3. So I've got here x minus 4.8 equals 5.3 cosine 3y. Divide by 5.3, that gives me x minus 4.8 over 5.3 equals cosine of 3y. So now something we don't practice nearly enough, but when we're solving a trig function, now I want to get rid of the cosine, we use inverse cosine. Okay, and we as teachers have been kind of lazy. We don't make you guys show this enough, but that's how you're going to solve this. So basically what happens is those two now cancel, and I'm left with 3y equals all of this stuff. So that gives me 3y equals inverse cosine x minus 4.8 over 5.3. And now I just need to divide by 3. So I'm divide all of that by 3. Now look at the notation they want you to use. R equals f inverse of x. So R equals f inverse of x equals all of this stuff here. Okay, so I just have to write that down. Inverse cosine x minus 4.8 over 5.3, and then that whole function over 3. Here's another example of a periodic function. Galveston Bay, the high tide today occurred at 8 a.m. with a depth of 18.7 meters, and the low tide at 2 p.m. with a depth of 4.1 meters. Sketch and label the graph showing depth of the function of time. So what we want to do first, I need a little bit of room here, is we want to set up our axes. And you want to be pretty neat. You're not going to be given a grid. This is going to be done freehand. They want you to understand how to create these periodic functions. And you can set your scale however you want. But if 0 is midnight, obviously I think it's a good idea to go by ones. So let me create a scale down here. And I know I need to go out to at least 2 o'clock, probably further. So let's see what we got here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That'd be midnight. 1, 2. Probably have to go a little bit further. 3. Actually, you know what? Let me keep this going. 13, 14, 15, 16, 17, 18. Okay, now I know low tide they said was 4.1. So what I'm going to do is I'm just going to put a mark here at low, 4.1. I'm just putting a little bit of break. And then high tide they said was 18.7. Okay, so this right here I'm going to label, that's t equals hours past midnight. And this axis here is going to be depth, and that was in meters. So the first thing I like to do, I know I need to get, plot those two data points, but when I see my axes like this, what I want to do first is let's get this midline value right here. And it's done pretty easily. It's a simple calculation. You're just going to take the average of 4.1 and 18.7. So if you add those two and then divide by 2, I got 11.4. I actually like to sketch that in right now. Okay, so going back to the question, it says 8 a.m. high tide 18.7. So I'm going to find 8 a.m., which is 8 o'clock, and that's going to be high tide right here. Then it says the next low tide was at 2 o'clock, and that was 4.1. So 2 o'clock p.m., I should have mentioned. So it's going to go past 12 noon and then 2 more hours. So right here. So now I have a maximum value and I have a minimum value. Okay, so what I want to do next, I want to find where it crosses that midline. So first thing I'm going to do is find the distance between these 2 points in terms of hours, and that's 6. So halfway between 6 is 3. So from 8 o'clock, I go 3 hours. 1, 2, 3. That's 11. That's going to be on my midline. So now I've got half of the period sketched. And the rest of the data points are pretty easy to get because I know the distance from one critical value to another is going to be 3. So every 3 hours, I know I'm going to go from a minimum to a midline to a max, and I can just repeat that process and work backwards as well. All right, so let's be careful when we do this. So this is at 8 o'clock, and if I want to work backwards from 8 o'clock, that puts me at 5. So at 5 o'clock, I'll be at the midline. Another 3 hours from that, it's at 2 o'clock, I'll be at the minimum. And if you notice, since we're going in 3-hour blocks and I'm at 2 o'clock right here, this is not going to get back. It's not going to intersect right here at the midline, which means I'm going to have a phase shift. Okay, and let's just do one more over here from 14 to 17. I don't know if I'll need it or not, but that's a good sketch. Okay, so there's a sketch. That's part A. Now what I need to do is come up with the equation. Okay, so I've answered that. Sketch and graph. Yep. Find a trig equation that models this function. All right, so part B. What I need to do is I need to find the amplitude. So again, remember amplitude is simply the distance between these two right here. You can subtract those. You can pick these and subtract those. That's pretty simple math. My amplitude was 7.3. Next, I'm going to do the period. Remember, the period is the length of one cycle. So there's a couple ways you can do it. This right here, from high to low, is half the period. So you can just double that. Or you could go from low point to low point and just take these values and subtract those, however you want to do it. But the period here is going to be 12. And then your b value is going to be 2 pi over the period, or you can simplify that to pi over 6 if you'd like. Let's see, what else do we need to get here? We do have a midline, and that was y equals 11.4. And there's a phase shift. Now, there's a couple ways you can do this, all right? So phase shift, you can have any phase shift you want. I'm going to create a negative cosine equation. So I'm going to take a look at this section of the graph. So my phase shift would be how far I have to go over here. If you want to create a positive sign, you could start here and do this. In this case, your phase shift would be 5. You could create positive cosine starting there. So there's any number you can do. I'm going to start here because it's got the smallest phase shift. That's going to be a negative cosine. So my phase shift is going to be right 2, and I'm going to do a negative cosine. All right, so here's what my equation is going to look like. Y equals negative amplitude 7.3 cosine. My b value is pi over 6. And then in parentheses, you have to include your phase shift, so that's going to be x minus 2. And then your midline is 11.4, so it's going to be plus 11.4. Now, for part C, what they want you to do is they want you to, swimming is only allowed after 8 a.m. and when tide is less than 14 meters. When is the first time kids can swim? So this is going to be calculator active, obviously. And what you can do here is you can create a little sketch. So in y1, I'm going to put my trig equation I just came up with here. So I'll make that y1. And I get something kind of looks like this. And then for y2, you want a tide of less than 14. So that's going to be your y2. Now, notice what it said. If you look at your sketch up here, it said after 8. So after this amount of time. So I'm basically looking for this point of intersection right here. So I know it's not going to be the first one, but it's going to be the second one on my calculator. So that means I'm going to be finding this point right here, P1. So for this one, please make sure you're in radian mode. And if you throw that in, sorry, I can't show you that on the calculator right now. But I got for a point of intersection 10.3 0.04506, something like that, 14. So for the sake of this, I'm fine if you say like between 10 and 10:30 a.m. That's totally fine. Give a half-hour interval. Or for those of you that want to be even more precise, you could take this 10.30, let me see here, 4506, and go DMS. Even though it means degrees, minutes, seconds, it works the same as hours, minutes, seconds. So if you do that, you end up getting 10:18 a.m. So I'd accept either one of those answers. Number 6 is another periodic function. This one talks about the number of hours daylight as a function of the day of the year. And we're looking at Prudhoe Bay, Alaska. The function has two minimums, s of 0 equals 1, s of 365 equals 1. A single maximum, s at 182.5 is 23. So what I'm going to do here is I'm going to make a quick sketch of this. All right, and we go from 1 to 23. And s of 0 is 1. So I'll use a different color. And then I have 365 here. Half of that's 182.5. Half of that is 91.25. And between these two, that's going to be 273.75. All right, so we've got a minimum at 0. We have a minimum at 365. We have a maximum at 182, so I can see what's going to happen here. I've got a midline. And my function is going to look like this. So the directions just say to identify the midline, amplitude, period, and frequency. So to get my midline, what I like to do again is just take the average of those two numbers. 1 plus 23 divided by 2. So obviously my midline is going to be 12. All right, so maybe you want to write that down first. Midline, again, just be careful here. College is a little bit picky. They're using function notation, so I'm not going to say y equals. You could say h equals. You could say s of d equals, but remember, it's going to be an equation. Amplitude, again, that's pretty easy to find. You just have to subtract those or subtract those. Either way, it's going to be 11. Period, again, pretty easy, 365. And my frequency is 2 pi over period. And that's all we need to do. We don't have to write the equation. It just wants those values. And our last one. All right, the population of brook trout living in a stream can be approximated by a periodic sinusoidal function. The number of trout t equals p of t is a function of the number of months since the beginning of December. That's 0. Population peaks at 950 trout as June begins. So again, that's halfway. And it falls to a minimum of 480 trout 6 months later before returning to its maximum at the beginning of June. Sketch a graph of this scenario over 2 cycles. All right, so I need a little bit of room here. Again, for this one, the key is going to be setting up your axes. All right, you want to do a good job of your scale here. So it says 2 cycles. I'm talking about 1 year. 2 cycles is going to be 24 months. So usually I like to go out there, especially when I'm sketching. Half of that is 12, half of that is 6, and half of that is 3. Okay, so my scale, I'm going to be going by 3s. All right, so what does that represent? That represents the months since December. And this is going to be my population. All right, so it tells us that the minimum population is 480. So I'm going to put 480 here. And again, put a little break in because we're not starting from 0. And the maximum is 950. So I'm kind of reading from my notes here. Sorry, I'm not scrolling back and forth. So I've got a minimum here at 0. And then in June, so that's 6 months later, The maximum is going to be at 950. And then in December, which is going to be 12, that's my minimum again. All right, so a couple things I like to do here before I continue this is get that midline. All right, so to get my midline, I'm simply going to take 480 plus 950. I'm going to divide it by 2, and that gives me 715. So that's going to help me get a little bit more accurate of a sketch. So I know right here between my minimum and maximum, that's going to be at 3. It's going to be right at that midline. And then at 9, so I'll sketch this as I go. Don't rush when you do this. And so I created my scale, so I know every 3, I'm going to be going to a new critical value. Midline, maximum, midline, minimum. So this is going to be a 2-year cycle. All right, so that's part A. Now, part B wants us to, let me just remind myself, part B, period, midline, amplitude, label these. All right, so this is going to be a little bit different. Label these parameters on your graph in part A. All right, so I have to list them, and then I also have to label them. So I'm just going to do that right here. Do something like this. Here's amplitude. I'll write what it equals down below. A couple ways you can do the period. You can just indicate one cycle. So there's period right here. Low point to low point. You go high point to high point, hill, valley. Doesn't matter. Midline is right there. All right, so now let's state those values. So for amplitude, I got 235 just by subtracting them. For my period, that was 12. And my midline, again, use that function notation. It's P of t equals 715. So that's what they want in part B. Now for part C, they actually want the equation. So the only thing I need to get for this one, I need to get a b value. That's going to be 2 pi over the period. You can use 2 pi over 12, or you could use pi over 6. And you want to identify what type of function is this, incorporating any reflections. So you could do a phase shift if you want. I don't want to do a phase shift, so I'm going to call this a negative cosine. So I'm just going to look at that right there, and I'm going to use negative cosine. So incorporating everything into this and using the function notation, I got P of t equals negative 235 cosine pi over 6t, and then plus 715. And finally, I apologize, I have to write small. Down here, what we're going to do is, notice it says here, determine when during the first year the population is above 800. Provide evidence to support your solution. We're going to do a graphic solution. I think that's the easiest way to do this. Not the only way. So what I'm going to do here is make a quick sketch. First year, I've got this. So that's going to be my y1. It's coming from here. And then I got a y2. And that's going to be 800. So basically what I'm looking for is I'm looking for this, where it goes above that. So I need to find 2 points, P1 and P2. So again, I apologize for not being able to put this into the calculator, but you're just going to throw that into y1, y2, make sure you're in radian mode, very important, and then just do your second calc intersect. So I came up with 3.7, 800, and 8.3, 800. So remember, this represents months since December. So basically 3 is March and 8 is August. 3.7 is still in March, so don't do any rounding here. So I'm just going to simply say between March and August. All right, guys, so that concludes the video answer key, if you will, for day 4 review. Please reach out if you have any questions or let me know if you find any mistakes.